The common use of the term exploits is in reference to a person's adventures or accomplishments. Our industry, in a sense, has perverted the term to have a more negative connotation. We really mean that we have computer code that takes advantage of a vulnerability in a software system. While that's great for penetration testers in order to do the job, there has to be a weakness somewhere for exploits to exist. Fortunately, the software industry does a great job in creating new vulnerabilities all the time. So I think there'll be lots of opportunities for exploits and penetration testers for quite a while. Let's dive into exploits and specifically Metasploit framework exploits. An exploit cannot be used without a vulnerability in the target system. In fact, most exploits require very specific vulnerabilities to be of any use at all. The conditions have to be exactly right for a specific exploit to be effective against a specific vulnerability. There's a larger discussion on vulnerability classification, attack surfaces, and risk that we'll not have right now, but let's zero in on the types of vulnerabilities that we can use with the Metasploit framework. You'll find a good number of vulnerabilities are related to memory safety bugs in software. These are generally the buffer overflows, dangling pointers, double free problems, and out-of-memory conditions. Not all memory safety problems lead to vulnerabilities. Most that do will be buffer overflow issues. These allow code injection for payloads. Privilege escalation is gaining additional privileges on a target system. These bugs can allow a low-level user to gain or switch privileges with another user or the administrator of the system. There are two types here. Horizontal privilege escalation occurs when the attacker gains access to another user or the privilege level of another application. This escalation allows the attacker access to additional protected resources. For example, the attacker might gain access to another user account with access to protected intellectual property. Vertical privilege escalation occurs when the attacker is able to gain a higher level of privileges and access a wider set of resources. In this case, the attacker might have the same level of access as the system administrator. If a software system does not check the input it receives from untrusted sources before it uses that input, it can have input validation errors. These types of bugs include code injection, SQL injection, format string attacks, cross-site scripting, and others. SQL injection is a favorite bug of some testers given the level of access to sensitive data and the ability to manipulate it. These three are not the only types of vulnerabilities, but they are the ones that you will most likely encounter in penetration testing work that lead to access. The Metasploit framework includes many exploits. The latest version I have includes 1,517 to be exact. So let's talk about the Metasploit framework exploits. Remember that most everything in the framework is a module. Exploits are no exception to that. As modules, you'll find that newer ones will show up all the time. You can even create your own Metasploit exploits or incorporate exploit code into an exploit module. Exploits are organized by platform and the service affected along with a unique name. They're located in a directory structure in the Metasploit framework files if you want to look at the Ruby code involved in the exploit. Thankfully, everything is searchable. Each exploit has configurable options. Some of them are required. Some have default values that can be overridden. Perhaps the most important option to configure for your exploit is rhost. That's the target system. You may recall from the scanning demonstration that the Metasploit framework module we had used had a plural form of this option, rhost. That one allowed for multiple targets and could even accept CIDR notation. The option for exploits is the singular option, rhost. Some exploits are specific to the type, version, or configuration of the target system. We may have to include a very specific target type to ensure the exploit works. There may be an option for the exploit to automatically select the target, but check the documentation to be sure. Once the exploit has been successful, we need a payload to inject. This option is used to set which payload to use. Of course, there are many options that exist. We will look at some of the commands in the Metasploit framework console that show us the options. Let's look at the naming scheme used for exploits. Exploits are organized into a directory hierarchy based on the platform, service, and a unique name. The platform can be a simplified name for the target system. Here are just a few examples with Windows, Linux, Mac OS X, which is shortened to just OS X, Firefox, and Multi. Firefox refers to a client-side platform. Multi refers to an exploit that can apply to multiple platforms and probably has platform-independent code. The service is also a simplified name for the target service. Examples include email, which is generally referring to email clients like Outlook, FTP, MySQL, MS SQL, and SSL. SSL is not a specific service, but is used in a variety of services. Each exploit under the hierarchy of platform and service has a unique name. These names can vary. Some are based on a specific security notification or Microsoft Security Bulletin. Here's an example. This is the name used for the 11th 2004 Microsoft Security Bulletin. Other names could be based on a specific software package and may contain the name of a vulnerable component. Here's one for the HP LoadRunner software and the specific vulnerable service. Knowing how these things are named makes it easier to locate the exploit you need. Let's look at the Metasploit framework commands that you'll use for the configuration of exploits. We'll focus first on the commands used to find exploits in the framework's collection of exploit code. The command show exploits will list every exploit in the system. Currently, that's over 1,500 exploits. This may not be your best option to find a specific exploit. Thankfully, you can search. There are several parameters to search, so use the search-h command to find out how to use those. Search will explore all types of modules in the framework. To limit your search to the exploit modules, use the search command with the type:\exploit parameter. You can also use additional search parameters as well. Personally, I have some trouble with the search feature. It always seems to return more results than it should. You may need to experiment with it to find what you're looking for. Once you narrow down the field of exploits, you can pull up the documentation from the exploit code author to learn more about the particular exploit. Use the info command along with the full path name of the exploit. Here is that naming scheme we discussed. The full path will include the platform, service, and the unique name. The information displayed will include a short description, the names of the authors that wrote the code, the platform it applies to, as well as license, target, payload, and reference information. Once you have the exploit you want, you need to configure it for use. The use command will select the exploit and load that exploit code. Notice that once the exploit code is loaded, we are now in the context of that exploit module. To show that, the command prompt for the Metasploit framework console will change to include the keyword exploit and the unique module name. The show options command will show all of the options available inside the exploit. It will list the name of the option, its current setting, whether it's required, and a description. With the option list, you can begin setting the options you'll need to use the exploit against a target system. In every case, you'll need to set the rhost option. This is the option that lists the target, and it is required. Depending on the requirement of the exploit code, you may also need to set the target. There's a number assigned for each target type. That number and the unique target system characteristic is listed by the info command. Some exploits provide an automatic targeting option. Be sure to check the documentation to determine the reliability of the automatic target option. Sometimes you will have better luck if you set it yourself. Once the exploit is configured, you can run it. Well, not quite. We still need a payload configured, which is our next section. Hang tight. Assuming you have it all ready to go, there are two commands to know. The check command is very useful when it's implemented in the exploit code. It can connect to your target system and verify that it's vulnerable before you exploit it. Again, not every exploit has this, but it's useful if it does. The exploit command launches the exploit code, the payload, and will make the connection to or accept a connection from the target system. You're probably excited to run the exploit command. Hold on, though. We still need to talk about payloads.